Hello, everyone. So let me welcome you to our presentation. I guess we can start already. My name is Vladimir Hlavacek, and we are going to show you how to build web applications with two Monorepo frameworks. One is Turborepo, and the other is NX. I'm leading the Techar group in Danubia. And I've been working mostly with banking and telco clients in the past. And my current project is actually using one of the tools that we are going to showcase. We are using it quite heavily for a longer time. So we decided that we make a little bit of comparison, and I think this will be interesting also.
Yeah, and hello everyone. So my name is Jan. I'm at Accenture for about 7 years and working mostly in the front end with large scale projects currently in the insurance industry. And also we have multiple teams and multiple applications running in a Monorepo, but kind of different one from what we're gonna present today. So I would like to talk about it as well as we are running the project and how we build things and etc. So so let's jump in. So what is Monorepo? Does anyone has any experiences with Monorepo? Right? Cool, perfect. Yeah. So you might have some questions at the end then. Hopefully there will be some. So Monorepo. Monorepo basically it's single repository which has multiple different applications living in, and the main the main advantage is that you can have a multiple individual teams collaborating in one repository without conflicting each other. Whereas when you have a regular repo, that's basically you maybe have experience with when you are running the Angular or React application. You just install it and everything lives in one directory. And when you wanna have multiple dependencies or multiple teams working together, you need to have, and you wanna share code, you need to have a different repository which lives outside of your primary repository. So here comes the Monorepo, which helps you to kind of combine and group them together and make a connection and dependencies between the dependencies and between libraries and applications. So why you should use Monorepo? There are six. I think there are 6 areas which are the most common in regards of Monorepo. The first is atomic changes. So when you have one commit, when you do one commit or one change in a directory or in a shared component, then everything which lives in the repository is changed within one commit. You don't need to go into another repository and do the update there. You just have one change which basically commits everything. Then consistent tooling, which is great thing because you have one set of tools, one set of commands that you control that repository. You then shared code and dependencies, which is quite obvious because you have the ability and the advantages of reusing code within one directory, so you don't need to go to another repository and do the change there. Also code ownership, which is the thing that we are using in our project, because you have multiple teams and each team is responsible for one application and they understand the application the most. So they think I'll take all the responsibility for it. And so the easier onboarding. So you have as I mentioned, you have multiple teams within the Monorepo, and you have people switching between these teams. So it's easy to switch one developer to the other team because we have the same set of tools. and everything is basically in one version. So you always have a one master at a time. So yeah, I would like to say that's the six most like important things.
Okay, so I mean, how do you actually work with such Monorepo, and how do you build it? And maybe I will give an example, like what can be in such a Monorepo, right? So typically you have the source code, and this can be it's one repository, and there could be, for example, one team who is managing, for example, your libraries for UI, maybe some themes, inputs, and so on. So all the common things. Then you have another team who is maybe security experts who are handling all the authentication, how do you log in, how do you authorize in your application, and so on. And then you have more, let's say, business-oriented teams who maybe do e-shop, e-commerce site, like a shopping cart, some reporting, product lists, invoices, and these kind of things, right? And all of the source code is in a single repository for a single. I mean, it's actually multiple products, multiple artifacts, right? But it's all the people are working together in one repository. For example, in our case, we have like 20, 30, I don't know, it's like 30 plus developers who are actually working on the same code base, but they're building different things. And now you have all of this source code, and you need something which actually takes this and creates new artifacts that you can actually deploy, right? So what does it mean? You maybe need a shopping app that you put to your cloud or or on premise. That's up to you. You maybe have another reporting app. Maybe you publish a component library because it could be that other people would like to use this, or you have a storybook for that library. These kind of things, right? But also important is, beside these artifacts that you actually publish, that you build, another thing is also things like test reports, code quality reports, and all the other like quality assurance that you have for your code, right? And this is all the responsibility of a build tool in a Monorepo to actually put this all together, right? So you have many folders, many dependencies, cross dependencies across them, and the build tool kind of has to make this mess work, right? That's the idea. So what can you actually expect from such a build tool, right? So of course, it's a build tool. It has to execute tasks. It has to execute compilation, running tests, and so on. So you all know this, right? But it needs to figure out a dependency graph. So it needs to find out which library is depending on which one, which project, which running application is depending on what, and so on. And now comes a very important thing. You have these many people working on the same repository, right? And if one team, one developer changes something, you actually don't want to rebuild all the other stuff, right? So what these tools are actually doing, they're caching, and caching quite a lot, right? So you change one part of the repository, it looks inside the cache, it sees that all the other stuff is already built there, I don't need to recompile it, and then it can actually use that cache to speed up the builds very, very massively, right? And not just the builds, and I will show this, it can speed up also the other tasks like linting, running test cases, all of basically all of that automation is there to really speed up the builds and make them fast. Of course, they need some support with the continuous integration. Why I'm mentioning this is, for example, if you have this cache, you need some way how to store it between the builds, right? So there needs to be the support, some sort of CLI so that you can run it automated and so on. And these tools, actually, they provide additional goodies, and actually NX is very good at that, so Janči will show that. They are like code generators, this remote caching that you can store it somewhere else, support for Docker, running some documentation tasks, parallelization of builds, and these kind of things, right? So that's like additional stuff. I mean, main task is building your repository, but typically you get also these things in addition. And then Janči will give a short introduction to NX, and let's see.
Yeah, so NX, like another 6 topics. I like 6. Anyway, so Yeah, the NX. Basically, these are the highlights of the NX, I would say, and I think that Turbo has the same, but kind of a little bit different. So NX is mostly about like Vlad mentioned, about building stuff. So it contains building tools. So it's on the first place, it's a build system. Then we have the computation caching, which Vlad mentions. Also the module boundaries, which is very helpful when you have like multiple teams, and there can be very mess between imports and dependencies. Automated update dependency, the dependency graph, and extending NX, which is quite useful when you have something custom. So build system, we mean by the build system, we mean that it has all the tools you need for the development. So imagine you want to create an Angular application and a React application and Node.js application within one single repo, right? And you don't need to go like the down level and set up everything like Webpack and all that stuff. You just grab these tools and generate the whole application for you, so you can scaffold controllers, whatever services for you. So there is a bunch of tools for it. The next one, the module boundaries, which I mentioned, it's a great thing that you can define which modules, libraries, packages can import what libraries. Like for instance, we have this source stack, which is Node, so we can define that Node application like API can only import libraries which has tag data, right? You cannot import anything which is UI related, for example. So that way you can really speed up the build process, because when you're importing something which is UI related into the Node.js, that might like take longer to build, and also may result in some errors. The dependency graph, which is quite useful, you can see all the different dependencies you have within the repository. It has also a nice feature that only those changes which are committed or are going to be committed are shown in a graph, so you can really see what you are going to affect with your changes, what libraries, what teams, and so on. Computation caching, so that's really speed up the process of building. So you build only once, and then for the second time, it just grabs the files from the file system, and if there are no changes, it just builds like instantly for you. So you don't need to really wait long. And this is quite like important, because that repository can be really large and may have lots of dependencies. And automated updates. So you know that when you have teams that spend a lot of time to really solve dependencies within the sprint, it might be a really difficult task. With NX, it's just a really 3 simple steps. It just migrates everything for you in a couple commands, and then also when you run the migrations, which are a result of that update, then also it updates your code base with the latest changes. The last thing, extending NX. So if you find something that is not within the NX plugin registry, you can also create your own plugin and run the commands and generate the code and everything. So yeah.
Okay, I will make Turborepo a little bit shorter. Turborepo is a little bit younger than NX, right? So it's kind of a newer tool, also taking a maybe a little bit different approach from NX. It doesn't have support for different languages. It's a build tool to build JavaScript and TypeScript, right? So there is no support for Java or something else, but it does this, I would say, really well, and it's kind of lightweight, right? So it's something that you can add to your existing repository, make it use, and actually make it speed up the builds, make it help you to build a monorepo. It's relying on other tools, right? So like package managers, some other tools to actually help you, which also kind of helps the learning curve because it's using the tools that you already know. And it has very great support from Next.js. This may be obvious because it's also currently sponsored by the company that's behind the Next.js, right? So with this, we will probably get to the code and show you how a project is built with Anix and how it looks like when it's built with Turborepo.
Yeah, so let's jump into code. I will show you first how we run it in Anix, how we have the application set up. You see that? Good. Okay. All right. Okay. All right. So we have two like folders here, which is one is Anix and obviously one Turbo. So the application is basically, I'll show you here. So we have a feedback form when you do some input here, and then on the left side or the right side there is a result of the feedback form. So basically there are two separate applications which share some of the functionality, some of the code. So we have here in a folder there is API, that's a Node.js application, which basically stores the data and provides the feedbacks. Then you have the dashboard, which displays all that feedbacks from the user and the actual feedback form. So basically, this Monorepo is divided into three separate applications. So each team can have a responsibility for each of these applications. And then we have this lib folder where you have all that shared code. So you have, for instance, model library where you have you have feedback definition, right? This could be shared from the UI and also from Node.js. Then we have this service which provides the data from the node, and it's used by the Angular application. And then Tailwind, so Tailwind provides configuration for both dashboard and feedback application because you want to share the same style for both applications, because by default when you create the application on the Tailwind configuration, it generates Tailwind the config file for each of the applications. So you want to have one place where you can tweak styles, and then UI shared component library where you basically have we're using the rating component, which I will show you. That's a shared component for dashboard and for the feedback form, and the header, which is kind of like cross shared as well. So this is the basic structure, and also we can take advantage and use Storybook kind of share and see how the components are behaving. So back to the application. So these are two separate applications, right? These are living on different ports. So if I don't know, submit something here, and it instantly goes here. So right, so this is running on different ports and sharing the same API between. Another cool thing, which you may see here, is that the dependency graph. So here we can see what depends on what. So if I show all the projects, we can see that the dashboard application depends on the services, the UI, and the Tailwind presented feedback also on the services UI shared, and the API only depends on the model, which is kind of library which only contains the data and the data interface. Yeah. So I think that will be it. Maybe I can show some more commands. Maybe. So maybe some of the build process here. So how the caching and the build process works. So sorry. Okay, so nx, then you run nx command run. I'm going to build feedback application. Build. I'm gonna use it, but build it using the cache. First run you running without. Oh no, it's running through the cache right now. So it says like the feedback has two dependent projects which needs to be built, and they're running from the cache. Yeah, I'll change one and I'll.
Let's see how the cache is triggered. change the title on a web UI or whatever.
All right. So if I run this again, I guess it will be fast, right? It gets built. And then if I change something, maybe in this service I will remove one of the conference title. So
Or it was too far.
yeah, so it's building like it's not using cache. Maybe cache.
I think it depends which thing you are building, right? Because the API is probably built always, but if you would change the library, only that part
Well, I
will be included.
change the service, which is the library itself. So if I change a model here, it's also dependency. If I change, I know, let's say that will be required, the feedback. And now if I run it again, you see that that's the one dependent project is running from the cache, and the second one has to be rebuilt because I changed the model library. Yeah. All right. So, and also that it's also important to mention that each project has its own project JSON config file, which is bigger. Wait,
You need
right.
Gen
Yeah.
to stop.
So basically, that's a configuration file for each application, each library. It consists of like the name and then source root and so on, and also it has targets, which are basically the commands that you can run. So I can run build. It has its own like configuration, then ser, which like executing dev mode kind of lint testing, right? And also Prisma generate, which is also like NX has a Prisma generator, which can provide you the Prisma tools, so you can run the database within. Yeah, so that's a project JSON file. You can configure that by yourself, but this is something which is configured by the generator by default. And yeah, and when you are using VS Code Studio, you have this nice NX project review, so you can build from here just by clicking, right? You have different set of generator and commands here. And what else?
Maybe I can show Turborepo a little bit.
Go ahead.
So that
time up.
Yeah, because we can spend a lot of time, but we want to compare those tools a little bit. So I will maybe make this. I will go to the source code, and the Turborepo application is very similar, right? So I think you have it open here somewhere.
No.
Is it or?
I need to run it.
All right. So I will go. And the project setup is actually completely different. So in Janči's project was Angular, NX, and so on. In my project, it's Next.js, React, and Yarn. He used NPM. So we really wanted to combine like all the different stuff. In my case, I am using the new Yarn, which is quite good. And that's why I said that that Turborepo is actually relying on other tools to do stuff that they do well. And how this is basically done is first they use the standard package.json structure that you all know from all the other projects. But what it has a different thing. It's using Yarn workspaces to basically define where are your packages, right? So by using these Yarn workspaces, you say, okay, so please look in apps folder for subfolders, and whichever subfolder contains a package.json, that's my project, right? So if I go to apps, and here I have web, where basically I have my package.json for my Next.js application, and I track dependencies the standard way as you are used to from any other project. So I have dependencies here, and I don't have a dedicated like project file as NX had. And you do dev dependencies and so on. What's maybe interesting is when you do yarn install or yarn to install the dependencies. I mean, it has all these different package.json files within all the different libraries and so on. But Yarn is very smart. So if you have like common dependencies, it actually places them into a single place. So in the central root node modules, if you have some project which is using a different dependency, in that case, it also can create a separate node modules folder in a specific project and place the different dependency into that one. So it kind of overrides that. So you are not, I mean, you are encouraged to use the same dependencies, but you are not forced to do that. So this is what kind of Turborepo uses Yarn for, but it has also its own file, which is called turbo.json. And in this file, you kind of define the tasks for Turborepo. For example, we define a build task, and what it does, it's basically running a build command in all the workspaces that you have defined. So in all the projects which you already have. And you can define what will be actually part of the cache in such case. So for example, I'm caching the outputs of a Next.js application in my case. And whenever I run the build, if nothing changed for this application, it's able to reuse the same cache. And then we have, for example, a specific task which can skip the caching. For example, when I run this yarn dev, I actually don't want to use the cache because I want to use the real code which I'm changing in real time, and that's why I actually want to skip the caching in such case. For the project structure, it's kind of similar what Jan showed. So we have a single web application, but in my case, we did one application which is like a composed, and then we have different teams who are working, for example, on the dashboard or the feedback or the feedback form, and there are some shared libraries like UI components and a database model. So, for example, database is a Prisma model that you may know, or with an SQLite database. And what's also Turborepo is capable of generating a graph for the dependencies. So I'm hoping I can show you that. But it's more like a static file that you can see. See? Thank you.
Nice.
And so I have the graph in a README file, which was kind of generated, and here you can see the dependency graph for a build task, how it is actually executed, right? So you have root web build, and it's depending on the dashboard and the feedback, which are like libraries, and then you have UI and a database. So this is the dependency graph for it. I mean, the real application actually looks similar as what Jan showed. So we try to do almost the same. I copied styles from him. Sorry for that. Yeah, it's a Next.js. So okay, we need to run the ratings. Never mind. So I can actually use. Let's try it. I need to run the migrations to generate the database.
Hi.
We go, and we should be back again. So, I mean, really, Turbo it's mostly about this one file, right? So you can easily put that into an existing project, keep the structure that you already had, and kind of use that. Also, Turbo does this caching, and that cache is actually stored inside the node modules and the cache folder, right? So here you can see the cached previous results. It also Vercel provides an remote caching. But for example, if you are on your own continuous integration, so for example, what we are doing, we are basically storing this folder in a cache and then reusing. Maybe one problem that we encountered with that, over time, that cache actually grows quite large. So you may want to have some sort of cleanup activities for such a cache, where, for example, we delete records older than some date, that way we can ensure that our builds have the cache, but still they are able. I mean, the cache is not so large. So this is how Turborepo is actually working mostly. I mean, it has additional stuff, right? So I mean, what we actually would like to speak about is how we can do potentially other tasks. Let me see, how can I go to slideshow? This one. How we can do the other tasks, but I think for these ones, we will be at the Accenture place. So at, what was the time? 16:40, I think.
Yeah.
So there we can talk about some of these, like how do you use specific Monorepo tools for specific things like Docker or publishing a library or whatever is like a typical stuff.
Okay, let's see if we have some questions. Oh my. All right, well, I see pretty interesting. All right, so is Monorepo usable for smaller teams, about 5 people, or is it a raw Git repository enough? Well, I can answer that right away. So I think it doesn't depend on how many people you have. I think it more depends on how many applications you build and how many dependencies you need to use. So you might want to have 5 people, which I don't know which like 2 are doing one application, that the other 3 are doing the second one, but they have their own responsibility for each application, and they might want to have a library which shared code between these 2. So I think it doesn't matter how many people, but more or less about how complex the system is.
It's all about tracking dependencies, I would say, right? So if you have many repositories and many dependencies between them, if you need to change an application, you find out that you need change in another repository to build a library, publish it somewhere, and then use it, right? In Monorepo, you do this on one place, and the dependency is there. It's one commit, it's easy to roll back, and so on. So these are kind of the advantages that you have. The next question is, how do you identify the artifacts which need to be rebuilt for a certain commit? It's the tools are doing it based on the file hashes, right? So if you change some file, they also take into account these build files that are in place, and they also take into account environment variables. So whenever, for example, an environment variable that you use for the build changes, it's also kind of invalidating the cache and rebuilding that specific library or that specific artifact. So go to the next one.
Yeah. one of the advantages of Monorepo that you stated is code ownership. How does it help with the code ownership when compared to multiple repos? Yeah, that's a good question. So, yes, when you have multiple repos and one ownership for one repo, then I think it's sometimes hard to kind of keep these repositories up to date and sync. So, for instance, you have application that's one ownership of one team, and then you have a different repository which is the ownership of the other team, and that repository might have some components which you want to share with the other teams. Then I think that's kind of hard to keep this in sync and really watch out for the dependencies, because something might change in that repository, and then the application might not have that updated. Need to really communicate between the teams. But when you have that in a monorepo, when somebody does change to the shared component, then he also needs to really update the other stuff, or at least notice the other teams that there is some change. Because when you do a change in a repository, you also have lists of merge requests in one repository, right? So everyone is able to look at the changes that are going to be and can review them and approve. So yeah, I'm not sure if that answered the question, but yeah.
Okay, I can go to the next one. How do you manage the version tagging? Do you have a common tag for all the services in a monorepo? Typically, yes. I mean, basically, the basic versioning is your Git, right? But still, for example, what we are doing, whenever we do a build that goes into production, we are basically tagging that specific build, of course, with Git tags. We may have a specific branch for code fixes. Good thing is that it's a single repository, so you don't have to tag multiple repos and multiple different libraries and so on. So just do it once. And of course, you tag the artifacts, right? So once the artifacts are built, they are stored in an artifact repository, and you basically use them. And I think I can answer also the next one. Do you also have infra and Terraform code in Monorepo? Yes, we do. And we basically use it we use a single repository to build the infrastructure, so to deploy it to the cloud, and also to deploy the application there. So it's all in one place.
Right, Links recommends to divide libraries into feature that access util and UI types to use this combination. Well, this really depends on the team, how they want to set up the monorepo. Basically, this also like the Nix has some recommendation as you mentioned, but you can like run your own setup, which really depends on the team. It's really up to you. But what is important here to mention is that you need to really care about what can be imported where. So as I mentioned in the presentation, so you need to really care if you have UI related stuff imported into the Node.js or something like that. So that might be a problem.
How do you handle cleanup of forever growing monorepo? I will maybe ask a counter question. How do you handle cleanup of multiple repositories? Yeah, I mean, it still requires maintenance, right? So you need to update libraries, you need to update like old code, put it away, refactor, and so on. The advantage of a monorepo is, again, it's one place. When you change something, you should have unit tests, linting, all of that stuff in place, which kind of will catch you in case you make errors. In case you have this in different repositories and you break the dependency, you maybe forgot to run the build for the other project and you don't know, and this gets into production. So that's all, which is actually much easier, and also the cleanup is much easier for you to do in such a monorepo. Okay, I think that was all. So we would very much like to thank you for your questions and for being here. Thank you very much.
Thanks. Bye.